Hi, science class. This is going to be chapter 15 of Unit D in Science 24. And so this one, we're going to look a little bit more into the physics of collisions, and we're going to practice with some of the formulas to figure out momentum and how much it takes to move things, how it is affected by mass, how it's affected by velocity. And we've probably heard of momentum before, but we're going to look at it a little bit more in depth and actually do some calculations to figure out what is the actual physics behind it. First, we're going to have an easy question. Which one do you think is easier to stop? If they're both moving at the same speed, which one will stop first, essentially? Hopefully we can figure out the canoe is much easier to stop rather than that big, huge cruise ship, because if they're traveling at the same speed, well, what's the one thing that's different? It's their mass. And so it's that same question of what takes longer to stop, a car or a train. They could be both moving at 60 kilometers an hour, but one can stop a lot faster than the other. Why is that? Because there's a mass difference. Before we jump right into some of the other practice questions with momentum, we want to go over a couple definitions. So take a moment, pause, copy down the terms here. All right, and now I want to draw your attention to the bottom corner, just something kind of interesting, where if you wanted to have the same momentum or kind of that same force or impact, if you wanted to talk about that, look how fast a mosquito would actually need to travel just because the mass of a mosquito versus a transport truck is so different. Kind of crazy. I don't think we can actually fly that fast though. Here we have our formula that we're going to use for the unit and for this chapter specifically. Please pause, copy down the formula, copy down what each variable stands for. And so here's an example of how we would actually apply this. And as we work through it, what is the momentum? So first things first, write out the formula. And then we substitute in. So we have our mass, we have the velocity. Multiply them together and we get what the momentum is. And we have 240 kilogram meter per second. Here you can see a few more objects that are flying at a certain speed and they have their mass. Take some time now, pause, and practice calculating these out, please. Perfect. Hopefully those practice questions went well. Now, when we're looking here and we're talking about momentum, we also want to talk about how do we stop or how do we slow down momentum. And for us, it's going to be applying a friction force or a braking force to actually kind of stop spinning wheels for us, whether it's in cars or on a bicycle, and we have to apply a force that actually slows down our momentum. Please take time, copy the definitions through here, and kind of see where we're applying braking forces on different vehicles. Pause here again and practice these review questions. I really want to bring your attention to number 3 and think about what each of these questions kind of means. If it helps, assign values to mass and velocity. And so the first one, if we had P is equal to mass times velocity, so we have mass times velocity, what happens if I put a 2 in front of there and I doubled it? And if I doubled the velocity, well, let's just say it was 1 for my mass, it was 1 for the velocity, and I was timesing them together. Well, that's easy. My momentum is 1. If I double my mass now, and I went 2 times 1, well, all of a sudden, now my momentum is 2 times 1 is 2, 1 times 2 is still 2, and so when I double my velocity, my momentum also doubled. Now, try and figure out what B and C will also do. This is where we feel the momentum changing. And what do we call it when we have a change in momentum? Well, you can see right here, we're going to call this an impulse. And so this impulse is the force and the time it actually takes. And this change in momentum, we also just call it an impulse. And so take a moment to read through the graph right below, and when we have a large force and a long time, we're going to have a large impulse. But how does it change if we have large forces or small forces, a long time or a short time? What happens with this impulse? Here you can see what happens when we have a sudden change in impulse. And this is a little YouTube video if you want to search up hard NFL hits. Yeah, there's some big collisions that happen here. And so when it's two colliding forces and this sudden change in momentum, when the direction changes suddenly, you have some big crunching hits. So something a little fun if you want to watch, or just kind of keep taking notes. Here is our next formula we're also going to use today. It is called impulse. And so we just talked about impulse as this change in momentum. And so we actually use the same letter for it, except remember we have that little triangle out front, and that triangle means change in. And so that change in, and then the P is called momentum. So it's still a change in momentum or an impulse, but we're slightly tweaking it. And so instead of mass times velocity, we're going force time. Take a moment, copy down the formula and what the variables stand for. Here, now we can see a practice question and what will actually happen. And so when we look at this force, I'm always going to kind of tell you, here's a force and it's 50,000 kilogram meter per second squared. And you see that clue is that meter per second squared. And you know it's a mass, but it's also a mass and acceleration. And so this 50,000 kilogram meter per second squared is going to be our force. And it happens over 2 seconds. So always write out the formula, substitute in our units for our given information, then multiply it through. And here is our change in momentum. And if you look, our units for momentum and change in momentum were the exact same, so we know we're on the right track. Here, again, pause, try out these questions, and you can see, yeah, big changes in momentum. I like these football hits. It adds really good perspective on what happens when we have a changing momentum or this sudden impulse. And so also, as we practice these questions to calculate, also think about these two questions below. What would happen if the impulse is applied over a longer time? And in collisions, which would you want to avoid? A short impulse or a long impulse, or that long change in the force or a short change? So please, again, pause through here. Hopefully we work through those calculations, but also now read through these questions and think these through kind of as thought questions or as we actually can write out some of them, okay? Please take the time. It's a lot of organizing our thoughts and getting all these terms in order. So pause, try these ones out. From my questions below, hopefully we thought of how we want to actually have this impulse change. And hopefully we want to have this force over a longer period. And so you can see the cars, whether you're gradually slowing down to a stop sign or whether you have a sudden one where you all of a sudden hit a wall. And so this immediate change in speed is going to be more force. And that higher force is going to have this larger change in momentum. And that's not going to be good for us when we're talking about safety and collisions. So in this example below, the velocity was the same. The change in momentum was the same. The impulse was the same. So what was different? Hopefully we kind of figured out that it's the amount of time was actually different. And so which one actually felt the greater force? Hopefully we're thinking car B as well. Here is a third formula for us. Yes, I know there's quite a few formulas, but we're going to make sure we keep them all in order with our study notes. And when we're working through, make sure to practice lots on when to use each formula. Here we have no new units really, so we have notes on what all the letters stand for, so we should be good there, but we do have a new order in which we are trying to actually calculate. And if we notice, right at the top, we have mass times change in velocity, and then we divide by time. And so remember, mass times velocity was just momentum, but when we divide by time, now we actually get a force. And so we're just slightly playing on that last formula where it was a change in momentum is force multiplied by time. And now we're just trying to figure out what the actual force is. So we just move some stuff around. A practice question will look like this. We have car A again coming to a gradual stop from going fast all the way down to 0. And so the change in velocity was 100 kilometers. What was the force involved in stopping a 1,200 kilogram car that was going 100 kilometers an hour in 25 seconds? So let's plug in our units into our formula. Here, as I walk you through it, you can see that I put in my mass and it's in kilograms. I have my change in velocity, and so what my final speed was 0 because I'm stopping. And then I'm subtracting my initial speed, and I want to use meters per second where possible, okay? If it gives me meters per second, I'll use that one. And when I subtract them, I go 0 minus 28, I get negative 28. So remember that for the next step. And then I divide everything by 25. And so I calculated the top, and that's where you see that negative 33,600. I'm going to divide it by 25 seconds. When I divide it by 25 seconds, I get negative 1,344 kilogram meter per second squared. This is perfect because don't be afraid of the negative numbers because they just tell you that you're slowing down or you're decreasing your force. Okay. Now, what happens? Oh, we saw it fly in. If all of a sudden, instead of dividing by 25 seconds, we divide it by 1 second like we see for car B. How would that change? If you want to, take a second, write it out. Or, as I can change it right here, instead of 25 right here, we'll have the same top. What if I divide by 1 second? Well, dividing by 1 second doesn't change the top answer. So all of a sudden, your force change is just this. And that's a big amount of force. And that's where you see a car crash happening. Now we're going to talk about, do we ever lose momentum? Well, no, we cannot actually lose momentum. We have this law of conservation of momentum, just like how we've had the law of conservation of mass, law of conservation of energy. We also need to conserve momentum. It's just lost in different ways when we have a car accident. For us, we're going to work in perfect scenarios where we lose nothing to friction, we lose it nothing to cars getting deformed and all this metal getting bent. We're just going to simply go A and B at the start, their total momentums, and then it is equal to A and B at the end. Maybe just some got transferred somewhere else. What we can also think is when we play pool and have those billiard balls when they collide and they bounce off of each other in a perfect world, because these tend to conserve momentum very, very well as well. However, when we're thinking of these questions and how things might react or bump around, it's best to kind of think of cars and how to kind of cars react when they collide together. So take a moment, kind of see through what's happening before a collision, what happens after a collision. So do we actually lose momentum with a head-on collision? Well, no. Because you think two cars going the same speed, having the same mass, they hit each other, then just nothing happens. Well, here's what actually happens. If they have everything the same, two identical cars, same speed, same mass, and they hit each other, they just cancel each other out. So what I'm going to do is Going to the right, going this direction, we tell it it's the positive direction. Going to the left is a negative direction. And you can see here, 200,000, 200,000, the exact same. We just use a positive and a negative to denote a direction. And what happens when you add 200,000 and you subtract 200,000? You get a total momentum of 0. And so it's not lost, it's just they canceled each other out. So now try this with a partner, or try to think in your head, what would happen with a head-on collision? So pause here, try to figure these out. And as we're working, if it helps, I included this simulation, and please hover over and kind of go to this PhET website, and you can go to a collision lab where you can practice having things collide, and you can change the mass and you can change the velocity, and you can see how they actually react with each other. So let's practice this out. If you want to, please take a chance, pause the video right now, and try to calculate out the total momentum, and try to figure out what is actually happening in the collision. Draw it out. It does actually help a lot. So as you drew it out, hopefully we see this happening. We have one car going this way. We have another car going this way. What will actually happen now? Well, let's figure out from this example what happens. We take the positive and we add it to that negative for a total of positive 80,000 kilogram meter per second. And they kind of collide and will hit, and they will move ever so slightly to the right direction. Here's another example. You can see where we're changing things out, but please draw it out and practice, please. Here I have a couple different collisions that are happening. Look through each question 1, 2, 3, 4, and think from collision 1, 2, and 3, what is happening with the differences in mass, with the potential differences in direction. Just think about it. What is actually happening? And of course, if we were in class, we can see a lot of hypercars or supercar collisions, and that's what this video was. So if you have a chance, you can obviously YouTube search this and find it up. But yeah, this is what happens when we have these sudden changes in momentum. If you wanted to search up that video, it was called Supercars Collisions. And so if you want to see people destroying very, very expensive cars, you can search that up on YouTube. If not, please pause, review through these questions, just as this last little review in chapter 15. And when you're ready and you've finished your cheat sheets, please let me know when you're ready to write the chapter 15 quiz. Remember, lots of practice, and make sure you have those formulas handy just when we have those questions pop up on the quiz. Good luck and take care.